All right, so now we're on the 4.3, and that's our absolute value function, right? So when we originally talked about absolute value, we had something like the absolute value of negative 13 is equal to 13, all right? Or we had the absolute value of x is equal to x. Whatever I plugged in, I made positive. So now I want to make it a function. I want to add a second thing. So first we talk about writing it. So we have the f of x is equal to the absolute value of x. Okay? This is our standard, this is our parent function. We'll get to that. But this is our basic form of the absolute value function. And if I were to graph that, what I would need to do is I first would need to find what's called the vertex. Because, spoiler alert, when this is graphed, it's going to look something like this. And this bottom of my V is what's known as my vertex. How I find that is, I set the inside of my absolute value equal to 0, and that gives me my x. Okay? So remember, this vertex is an ordered pair x comma y. So let's say instead of just x, I make it x minus 5 plus 3. Okay? If I were to graph that, I would first need to find my x value for my vertex. So I take this stuff in here, and I set it equal to 0. So I have x minus 5 equals 0. Then add 5 to both sides. Those cancel. I'm left with x equals 5. So that is the x value of my vertex. I know it is at 5 comma something. But how do I find that out? I make an xy table. It's really x, f of x. All right? So I plug in 5 to my function. 5 minus 5 is 0. The absolute value, I'll go ahead and do it. 5 minus 5 plus 3, that equals 0. Absolute value of 0 is 0 plus 3. F of 5 equals 3. So I want that term, just erase this, to be in my middle, right? Because it's a V. So I want some to the left, some to the right. So I'm going to put 5 in the middle, and I plugged it in, I got out 3. This is my vertex, okay? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So I go to 1, 2, 3, 4, 5. 1, 2, 3. That is my vertex. All right. I then need to complete my table. So I want to pick some numbers that are less than 5 and greater than 5. Easiest way to go about it, 4, 3, 2, 6, 7, 8. All right. I then plug each of those in. 4 minus 5 is negative 1. The absolute value of negative 1 is 1. 1 plus 3 equals 4. Plug in 3. 3 minus 5 is negative 2. Absolute value of negative 2 is 2. 2 plus 3 equals 5. This trend is going to continue. I then plug in 6. 6 minus 5, 1. Absolute value of 1, 1. 1 plus 3, 4. This is going to be 5, and this is going to be 6. And what you should start to notice is that at my vertex, I have this symmetry, right? And that makes sense because I have a symmetrical V as my graph. Okay? Then I need to ask myself, what is my domain and what is my range? So my domain is going to be all real numbers. No matter what I plug in for x, I'm going to get something out. Finally, what is my range? Well, my range, if we were to take this and squish it up against the y-axis, we can see that the first point I would come to is 3. And then it's everything above that. How do we say 3 and everything above? Well, we say it y such that y is greater than or equal to 3. If you just want to have y greater than or equal to 3, I will accept that, but that is proper notation. So basically, all you have to do, take this, set your absolute value equal to 0, solve for x, create an xy table with that answer being in the middle, plug in, you'll get some answers, gives you your vertex, and then all your other points. You then graph it and decide the domain and range. So hopefully this helps. One quick tip, let's say this would have been, I don't know, 1/2 x minus 5, okay? Let's make it 1/2 minus 6, all right? Just so it works out. So 1/2 x minus 6 equals 0, 1/2 x equals negative, or just regular 6, x equals 12. I guess I could have left it as 5, it would have been 10. So anyway, so I got 12 my x, my f of x. I would not go then by ones, right? Because if I went by ones, I would get 11. And then I plug that in, 11 times 1/2 is 11.5. But if I go by factors of that, so what's my next multiple of 2? Well, it's going to be 10, 8, 6, 14, 16, 18. I can then plug those in, so then I get 12 minus 6, that's 3. 10 to the half is 5, minus 1, or minus 6 is negative 1, so then I get 4, 5, 6, 4, 5, 6. All right, so the only time I wouldn't just increase and decrease by 1 is when you have a fraction. I would then use multiples of that fraction. So hopefully that helps, and we'll move on to the next.